Okay, I think we can get started. Good afternoon, all, and it's morning here in Trieste, and welcome to the workshop on scientific tiny machine learning on the use of machine learning on low-power devices for scientific applications. Just a few words about myself. I see some familiar faces among the participants, but many of you are I haven't met yet. I'm a research scientist at the ICTP, which is the Abdus Salam International Centre for Theoretical Physics in Trieste, Italy. I have been working on IoT since 2006, when this field was called wireless sensor networks, and then IoT, and now tiny machine learning. You can see some pictures from training activities that I organized in the past. I believe I organized activities in more than 30 different countries. So I have seen, in a way, the evolution of this technology. And in fact, I looked for the price of the first device I used in 2007. It's a device from Sun, and that was quite expensive. It was more than $500 for a kit of 3 devices. And now, if I look at the latest prices, you can buy devices for $5. So it has really changed a lot in the last 15 years, and that opened to many new applications and many interesting applications, I believe. So the workshop team, the organizers, there's myself on the left, there's my colleague and friend Rosadi from Malaysia, which we're going to talk shortly, and then Vijay Reddy from Harvard University. He's really the top expert in TinyML, and he will give the keynote through video, and he helped designing the agenda for this and similar courses. So you have, the top expert in tiny machine learning, as the organizer of this activity. So we have 100 participants from 8 Asian countries. So you see a map here. So going from west to east, you have Istanbul Technical University in Turkey, King Faisal University. We have Information Technology University in Pakistan. You have 3 universities in India, MIT World Peace University, Atria Institute of Technology in Bangalore, and the Indian Statistical Institute. Then we have Bangladesh University of Science and Technology in Chittagong. We have 2 universities in Malaysia, and I will let my colleague ID call them in the proper way. I will, the university Kebangsaan, that's really bad, in Malaysia, and the Technical University. We have Asian Institute of Technology in Bangkok, and we have Kobe Institute of Computing in Kobe, Japan. Here is the list if you want to see the names properly spelled. So we have different time zones. And in fact, we have this limitation of 3 hours per day because we're ranging from, late morning to almost evening in Japan. Some statistics about the participants. We have about 70% are junior scientists. We have some regular, what are called regular in the ICTP naming, and we have 10% of senior participants. And I think this is quite interesting because we have many PhD students or young postdocs, which are part of the participants. So, and we have about 30% female participation, which is higher than the average that we have at the ICTP, which is about 25%. So very interesting group of people, and I'm sure that we're going to do really good in terms of interaction with this group of people. So you might ask yourself, why do we have a workshop on TinyML in an institution like ICTP, which is a scientific institution working in physics and mathematics? And I picked 3 examples where I think this technology can really play a big role. So the one on the left, that's a buoy in the middle of the ocean. and take some measurements about height of waves, about water temperature, about salinity, and about water quality. Point is that all this information has to be sent on the internet in some way. And that usually happens through a very thin connection. And in this case, it will be a satellite connection. And as you can imagine, sending all this information about water quality and water temperature is a challenge because, again, you have a very thin connection. So TinyML can play a role because you can understand when things are wrong, when these measurements are strange in some way, when you want to send this information because it's worth for scientists to know that some of these parameters are not, the normal ones. So you make sense of the measurements on the buoy itself, and then through this thin connection, you only send an alarm or you just send the data when it's worth sending it. Same is the example on the right. That is a rain sensor. And there again, if you want to measure rain in remote locations, you cannot send regular information because the connectivity to the internet is very thin. So you want to make sense of this measurement. And not only that, but you can also think about other ways to develop rain sensors. So this is a traditional rain sensor where you're measuring the amount of water in a mechanical way, but you could use an acoustic rain sensor to have a sensor which doesn't have any moving parts. So wide range of scientific applications. And then the picture at the center, that is CERN, and that produces huge amount of data per second. And again, all this information cannot be stored. It's way too much. So now they're using TinyML to make sense of the measurements in the experiment itself. So if something is of interest, then it is stored. If it is not of interest, it is discarded. So there's a wide range of applications. Those are only 3 examples, and I'm sure that you can think about many more examples where TinyML can play a role in science. To support these kind of activities, we created about a year ago the TinyML Academic Network, which I believe all your institutions are part of. And the goal is to develop a community of researchers and practitioners like you, focused on improving the access to TinyML education, and also to enable innovative solutions that are of interest in developing countries. And we do so by organizing workshops and seminars, such as this one, and you see there's many more that we organize regularly. We have an online forum where people can meet and discuss about interesting issues together. And finally, the open exchange of student projects, lesson plans, and real-world deployments and outreach materials. So that's the link, TinyMLedu.org, and you will see it is hosted again by Harvard University, and it's a quite active network. So we have 3 pillars, 3 activities in the network. The first one is to produce good training material. Second one is to provide network members with reliable equipment. And the third one is to have a human network. So good training material, we're working on that. There is already a lot of training material. If you go again to tinymledu.org/teach, you will find lots of training material from edX, from Edge Impulse, the Coursera course, a lot of training courses produced by Marcelo Rovai from Brazil. Those are open. You have, GitHub examples, you have the slides, and then of course you have all the training material from the existing activities that ICTP has organized. And the final goal is to provide open educational resources so that you can actually reuse this material in your university, adapt it to your needs, and share it with your students. If we look at the equipment, most of you will have 2 different types of kits. You will have the Arduino kit and you will have the Seed Studio devices. In this specific workshop, we're going to use the Seed Studio TinyML kit. And the fact that we have the same kit in each university is because that facilitates the exchange of code, of tutorials, and of projects. Okay, so if you come up with a solution, then you can share the same code to your colleagues because they're running exactly the same devices. So this is the reason why we're focusing on these two specific platforms. And again, in our case, on the Seed Studio devices. In fact, we want to thank Seed for their kind support. You have received this Seed kit through Seed Studio donation. So thanks again for the support. Getting back to the network, we have about 500 members in our Discord channel, and I believe you're already part of it. And if you're not, I will share the link in a second. But this is a very interesting platform where people discuss about projects, they introduce themselves, they discuss about technical issues. So if they have a specific technical issue, they post in Discord a question and they will receive a reply from this team, from Harvard, from Marcelo Rovai, from the Edge Impulse people. So it's really, really an active network. So we said logistics, we're going to run 3 hours per day in UTC time. So that is our standard, is from 7 a.m. to 10 a.m. You see most of you are already connected. So it means that you already know the correct time. So getting again to logistics, ICTP provides certificates of attendance at the end of the workshop. So in the days before COVID, that was easy. We met people in the lecture room and we knew, who attended and who missed the lectures. But nowadays in our world with Zoom, it's a bit more complicated. So what we do is that we use the Zoom log file and we check the attendance of at least 80% to receive the certificates. Okay, so the certificates are automatically produced at the end of the workshop when the log file of Zoom says that you attended at least 80% of the lectures. Getting back to the agenda, so we have the full week, so it's 5 days. This is the agenda for today. So it's going to be myself giving this short introduction. Then it's going to be ID from Malaysia, giving a short talk. And then we're going to have a keynote from Vijay Reddy. He sent a video because in the US it's late in the night. So he sent a video. And then we're going to have an introduction to machine learning by Meran Bejati from National University of Malaysia. And the reason why we do the introduction to machine learning is to make sure that we're all on the same level. So from your CV, some of you are experts in machine learning, some of you are experts in embedded devices, some of you are computer scientists with no prior knowledge of machine learning and embedded devices. So the introduction helps in making sure that we're talking about the same thing when we're talking about machine learning. And in fact, we added an extra session tomorrow morning, so 1 extra hour as the second part of the introduction to machine learning. Then we're going to get hands-on activities starting tomorrow with an introduction to Edge Impulse by Luis Moreau, which is an engineer of Edge Impulse. So very knowledgeable people. He will teach you how to set up Edge Impulse and how this system works to facilitate modeling. And then we're going to have Momodou from Seed Studio, which is going to introduce the Seed TinyML kit. And we're going to learn how to connect this kit to Edge Impulse. Okay, so tomorrow, at the end of the day, you will have all the tools necessary to get started with Tiny Machine Learning, both the platform, Edge Impulse, and the hardware, Seed Tiny Machine Learning Kit. And in fact, on Wednesday, we will start with one specific application, which is motion classification. So we will use Edge Impulse and the Seed Kit to classify different types of motions, and that is then useful for anomaly detection. I will cover the case studies in a second, so we're going to have a few presentations about case studies. And then we will talk about responsible AI. And as you will see, that is extremely important, especially in the tiny machine learning world, where these devices are deployed in some remote areas, or they don't have any internet connection, which means that you have to make sure that they're designed in a responsible and ethical way from the beginning. On Thursday, we will focus on another application, which has to do with computer vision and keyword spotting. So we'll use keyword spotting, so developing our own Siri or our own Hey Google kind of application. And again, it's going to be hands-on. We're going to have a very nice lecture, again, on video from Brian Blanchard, which is from Columbia University and previously at Harvard University. And then again, we have even more case studies. And then on Friday, we'll have a presentation about FOMO, which you will see is a very interesting video application from Sean from Edge Impulse. We're going to have two case studies about deploying these IoT devices in the real world from two experts, Apinung and Reginald from Thailand and the Philippines. And we're going to have a presentation from UNESCO about using these devices for disaster risk reduction. And then we're going to have a discussion about the research topics and the collaboration in the Asian region. I said that we have some space for case studies. So some of you propose some case studies. So the idea is, if you're working on some TinyML-based projects, if you already have some ideas, it would be really interesting to learn about these ideas. If you have been working on machine learning applications or on IoT applications, and you think that this TinyML can play a role, that would also be interesting to hear. If you're working on machine learning projects that could use tiny machine learning for development, so with a social impact, that would be, again, extremely interesting. ICTP has 3 awards for the best presentations from early career or from students from developing countries. So there is even like a small, award for the best presentations. So if you have a case study you want to present, please drop me an email. You see my address there, mzennaro@ictp.it, with a title, a short abstract, and your name. Okay, so please do that in the next few days so that then we can start on Wednesday with the case study presentations. Case studies are going to be 10 to 15 minutes long. So get straight to the point about what you want to do or what you're working on in the TinyML field. So all the material that we use for the workshop will be openly available for you to use as a teacher, as a student, as a practitioner. So here you find the webpage. So it's tinymledu.org/scientifictinyml22/Asia. I will put that in the chat in a second. And again, the videos, the slides, and the code will be available. Please have a bit of patience because Zoom takes a bit to process the videos. So at the end of the session, it usually takes 1 day for Zoom to send us the videos, which we can then upload on the website. But that also means that after the workshop in a few weeks, in a few months, you will still have all the material available, including the slides that you can use for your own training. And then you have the ICTP official. Okay. You please mute your mic. Mute. Can you please mute your microphone, please? Okay. So what is the philosophy of this workshop? It is described by this quote by Benjamin Franklin. So tell me and I forget, teach me and I may remember, involve me and I learn. So we really want to have this workshop as interactive as possible. So you're more than welcome to ask questions. If you have any question at any time, please raise the hand using Zoom. Okay, so click on the raise hand button in Zoom, unmute, turn on your camera and ask your question when you're given the floor. Okay, and so then at the end, please don't forget to lower your hand and mute yourself afterwards. So again, feel free to ask questions at any time through Zoom. But if you have longer questions or if you don't want to talk, please use the Discord channel. That is really, really important because the questions and the answers in Discord will remain after the workshop. Okay, so if you ask something in Zoom, once we're done with this session, all the chat, we're going to lose that chat. But if you do it in Discord, then all the questions, the interaction will still be on Discord even after the workshop. So please join Discord. I will add the link in the chat again in a second if you haven't done so. In fact, we will use the Zoom chat only for announcements. So to share links, to share short information, but all the interaction should be done through Discord. I think you have received the survey in the email. So please, fill in this pre-workshop survey so that we have an idea of what is your interest, what is your previous knowledge, and then we can compare it with the post-workshop survey at the end of the workshop. So please, again, I will add this in the chat in a second. And my last slide is just to thank a number of institutions. Well, of course, ICTP, the Harvard John Paulson School of Engineering and Applied Sciences, the TinyML Foundation, Google, Agimpulse, HarvardX, Arduino, ADX, and Seed for their kind support. So again, as you can imagine, when you organize a workshop, there's a number of people that help, and here is a list of all of them. So I think that is all from my side.